Alright, so in part 2 of this video, the sound is working now. Sorry for all the rattling. I don't know where the microphone is on this thing, so I'm going to try to hold this a little bit different, and hopefully you don't hear all the scruffling of my hand. So the answer for this one was A. It says the alternating series test can be used to show convergence for which of the following series? The alternating series, these are all alternating series because of, I see that positive to negative stuff going on. So they're alternating. So which ones have limits that go to 0 of the a to the n? The limit of that's 0. And the terms, I would say, are decreasing pretty obviously. So that logic of this denominator is bigger than this one because I add 1 and then square it. So if the denominator is bigger, the overall fraction is smaller. So that one converges. Okay, the other ones, let's skip down to 3. This one does not converge because I'm just going to see, not looking at the positive negative part, just looking at the a to the n, are these decreasing? And I don't think they're decreasing for the same logic from before. This denominator is bigger than this denominator. Oh wait, that kind of makes sense. Huh. Is that denominator? Okay, this one always confuses me. That denominator is bigger because I'm adding 1. So it makes it smaller. Okay, yeah, so it's backwards. That's right. So these are increasing, or at least at this point, they didn't decrease, they increased, but it needs to always be decreasing, or at least staying the same, never increasing. But this one increased, right? Sorry, I got confused with that again. That increased, so that's gone. And then the next one, the limit is 0 because this is sine, so it's going like up and down, up and down, up and down, but the bottom is just growing without bound. So the limit's 0, but it's not always going to be decreasing because we just said the sine is going to go up, down, up, down, up, down. And I think if you plug in sine of 1 into your calculator, it gives you a bigger number than sine of 2. So this one is not non-increasing. That one's increasing. It needs to be non-increasing. So that's why that was it. All right, these last 3, I realize on your paper you don't have enough room, so you might need to write on some scratch paper for these, especially this one. The other 2 are pretty quick. This one takes a second. So we want to see, does this series converge or diverge? There's the alternating part. So it's an alternating series test. I need to check, is the limit as n approaches infinity going to be 0? And without even writing this all out, I know if I multiply the bottom out, like FOIL FOIL that out, it'd give me n squared, so the bottom degree is bigger, so yeah, that's 0. Now I gotta say, is this thing decreasing, or at least non-increasing? And to do that, I'm gonna do that algebraic ratio, and so I'd have, I'm plugging in n plus 1 for all the n's, because I'm trying to show, is a to the n plus 1 over a to the n, is that always less than or equal to 1? Because if the next term is smaller than the one that should have been bigger, then the ratio would be less than 1. So I'm going to plug in n plus 1 for all the n's, and instead of doing n plus 1 plus 5, and then adding each time, I'm just going to do it in my head. So if I add 1 to n, and then n plus 5 be n plus 6, over adding 1 to that, n plus 3, n plus 4, over the original, I hope it's not like making all that scratching sound for y'all. But I'm not recording these again. Alright, so is this less than or equal to 1? Question. I don't know yet. Well, I do know, because I did it a second ago, but kind of hard to see. So I'm going to keep change flip. And I notice that the n plus 3's cancel. So I get n plus 6 over n plus... Oh, no, that's dumb. Over n plus 4, n plus 5. And you might be able to say that that's less than or equal to 1, but I don't know if we can really, really say that, if that's enough proof. You might use, some kind of logic, 6 times 2 is 12, and that's smaller than 4 times 5, which is 20. But there's another little trick I want you to see in case you ever need to use. So I'm going to multiply this through and get n squared plus 8n plus 12 over n squared plus 9n plus 20. You still can't really tell which one's bigger. I'm pretty sure the bottom is bigger, but to prove it, I'm going to rewrite. I'm just going to copy down the top. The bottom, I'm going to write that as n squared plus 8n plus 12 plus something. So what would I, notice I added, that's the same as the top and the bottom. What would I add to 8n to give me 9n? I would add n. What would I add to 12 to give me 20? I would add 8. Now I think we can definitely say without any doubt that this is less than or equal to 1. Because I've got this part which is the same, but I'm adding in, I'm adding 8, which makes the bottom bigger, obviously, so the overall fraction is smaller than 1. So we've shown both conditions. So I would say, so the series converges by the alternating series test. Alright, second to last one. You could pause the video if you want to, try this on your own. Here's your chance to pause it. Okay, unpaused. That's the alternating part. So I need to check, is the limit as n goes to infinity of the a to the n part equal to 0? No, it is not. If one of the conditions fails, the alternating series test says it diverges. Easy peasy. Last one. Okay, this looks different. Alright, what looks familiar, what looks different? Don't panic. Why doesn't it look like all the other ones that we've done with this little -1 to the n stuff going on? I don't see that. But I do see that this is the harmonic. So there's something going on. Let's see. If I was to plug in 1, start the series out, it would be cosine of 1 pi, and then 1 over 1, and then it'd be, I don't want to write that. Then it would be cosine of, plug in 2, so 2 pi, cosine 3 pi, cosine 4 pi. That's probably enough to see the pattern. Okay, what is cosine of 1? Think of your unit, 1 pi, sorry. So think of your unit circle. Pi is like the 180 degrees. The cosine there on the unit circle, the x would be -1. Cosine 2 pi, x coordinate there would be 1. Cosine 3 pi would be -1 again. Cosine of 4 pi, 2 circles around, is back to +1. So you might see it now. There's the alternating component. So instead of -1 to the n, you might see it as something like that. Cosine or sine of something that goes positive, negative, +1. which just tells us this is a converging, or converges. It's a converging harmonic series. All right, thanks for putting up with all the scratchiness. Hopefully we're able to keep up with our schedule since we watched the eclipse. And hopefully you didn't mind me kind of whispering so I don't wake up my kids. If you have any questions, we could talk in class tomorrow, but finish up that homework, try the practice, look on Canvas to see if the answers are what you're getting. Goodbye.